I'm quite excited to be there today because I will show something that took 3 years to be built, mostly, and started to enter in production in some customers. So I will talk about keeping your data in sync with your Erlang application with Barrel. We'll present Barrel. To just introduce myself, since it has already been said, so I created my latest company that I created. It was in Mnesia, which is mostly done to do some consultings and to provide some tools to the customer to build a data endpoint to my customer. I'm building custom data endpoint to the customer, meaning modifying database or writing some small database for it. And I'm also a member of the board of the directors of the Erlang Ecosystem Foundation. So to quickly introduce the context and why I built Barrel. So we live in a time where everything is on the cloud. We all put our data in the cloud mostly, and we lose more and more the control of our data. Why I'm building, so it makes us more and more dependent on that infrastructure. So if you put your data on Azure, it's really hard to put your data on AWS or keeping your data on your own clusters. So the main point of Barrel, this is not really a database. It's time to kill that ID. It's more a framework or a product that synchronizes and replicate your data between the machine and application. So everything inside Barrel is designed in a way so it can help you to replicate your data between different nodes in a peer-to-peer manner. So the main feature for which I created Barrel, and some are already there and some are about to come, is to be able to keep a partial state of your data locally, meaning you have a large set of the data. Of course, you don't want to have everything on your machine or on your mobile or on the server, and so you want to be able to migrate the data, and this is what is one of the parts that feature. To replicate the change of the data, so to allows you to route automatically any data based on a view of your data, a partial view or a complete view of your data. Everything is built in Erlang, and everything is open source without strings. This is not an open core model. You take the code, you do whatever you want to. I will take care myself to win my money with that and some other stuff. And Barrel core concepts. So like I said, this is built in Erlang. I don't try to rewrite some kind of storage. I don't try to rewrite a Btree in Erlang. I don't try to write anything in Erlang because the Erlang is not really designed for that. So let's just take what is already existing. So I'm using, so for that I've done a binding of Erlang through RxDB, which is some simple key value store created by Facebook in C++, and you have already a bind of that in Erlang. It's using dirtinifs, and it's mostly working like ETS, so meaning that you can, for you, RxDB is some kind of specialized process on which you put some key values from any process and you store on the disk. But of course, storage are pluggable because RxDB is really designed for the server side, but if you want to have something embedded on some small device that require less memory or less CPUs, then you can change the storage, like using SQLite or the Btree of SQLite more, or stuff like this, or more specialized storage. Everything is about back pressure inside Barrel because it has to work on small machines. So the cheapest one you can find on the cloud, so meaning that you have 2 gigabytes at least per hour with RxDB. You have 2 gigabytes and 1 or 2 virtual cores, something like it. It has to work on that with 2 gigabytes, 4 gigabytes of memory. So there are a lot of back pressure, which is on the by jobs, custom supervision strategies, and a lot of sensors that are added to Barrel to react depending on the memory or on the CPU to move the data. If you don't have enough memory or if you don't have enough storage, then it will move that back to some collaborators nodes. This is document I wrote it. So the core structure of Barrel are documents, but don't think it has some kind of Documents are more metadata that are stored in Barrel as maps or JSON with a revision. So you can write documents in any machine that you have in your cluster and replicate them, and each has a revision. For each document, we maintain a revision tree, like Git, which allows you to replicate the conflicts to any machine and do something with that at some point. This is not CRDT, even if you can buy CRDT on top of that. This is more to be sure that you have all the conflicts you want on the machine when you need to resolve the conflicts, if you have any conflicts in your design, in the data design. Barrel can work embedded or remotely. So you can, meaning that you can put that in your Erlang application, like Mnesia, or you can set up a node of barrels to simple node of barrel on which you will replicate the data using TCP. Or anything else needed for the job. TCP, just the default layer for now. Operations are very simple. Here you create a barrel. First, then you store a document. Here we are storing an empty document. It gives you back the document ID and the revision. You can use that revision in your applications. And if you want to store, to fetch the document, then you do the fetch docs application. The revision is here for two things. So first, it says that you have a new revision of the barrel, and if you want to make some kind of optimistic transactions, if you don't want to upgrade a document, you pass the revision to the documents, and if there is if the revision of that document already moved, if this is not the winning revision, then it will return your conflicts. But it's also here to, like I said, we are onboarding a revision tree with each document. So when you put a revision on that document, it says basically who is the parent of that document, and then you can share that revision tree over the network, just like it, but for documents. Like I already said, you should consider properties inside documents as metadata. Which is more important is that you can attach anything, any blobs, which is either uploaded to Barrel or just you put an HTTP links and it will be replicated by Barrel. It will figure about that. So it's kind of interesting that to have that. So for a customer, for example, we built secure message systems, and you use the properties as metadata, the thing that you can read, that allows you to replicate the data, and you store the encrypted part inside the blobs, and it will be decrypted by the clients without, so it gives you a zero knowledge on the server side if you want to. So there are a lot of things automatically indexed. So by default, you have the document storage, which index everything by IDs. You have the persistent views that I will show you what it is, and the database change. You can query any change in the database over the time. So what are persistent views? So maybe some of you knows CouchDB, and you have the views that are map reduce function mostly. And I reproduced that in Barrel, which is normal because Barrel started a long time ago, very long time ago, as a fork of CouchDB before being rewritten from scratch. So views are map function in Erlang that return a list of key values, which is different from CouchDB. So it doesn't return one key value or extra, it returns a list of key values. A key is a tuple, or a list of small keys on which you will be able to query. So you can query a part of the tuple. Just if you want to query anything, any document, anything in your views that start by E1, you just pass that path to the query engine. And you can query any part of the tuple. And the view function is that simple. So by default, everything is in Erlang, in Barrel. So you create a module. And in that module, you have an handleDocs functions, on which you pass the document and the configuration that will receive the configuration and the document that will set. And then you return a key value, a list of key values after processing the documents. By default, you can find in Barrel a dynamic ARS record, which is atom record sequence and database engine, which index everything, every document that came in that views and create paths. So if, for example, you have that data structure, ID, location, and subproperties, country, cities, etc. It flattens the document, create the path. Each path become a tuple in the database, and then you can query the database by path inside the things. So everything can be indexed in real time. That way, in an eventually consistent manner, or in a consistent manner if you're copying the doc during the process of indexation inside the view too. So querying a view is really simple because it has to work over the networks, and you may want to filter some parts or merge some dynamic parts coming from different nodes. So the base of the view of querying a view is so once you started a view, you are querying a view, or you are getting a range on that view, passing some functions, beginning of key, saying if you want an inclusive range or not, using begin or equal, end or equal, if you want to get it reverse way or forward. And then you get a stream process, and then you can start to resave documents. It works by default as a stream, but you can also work it in acknowledge modes, saying you get the data and you get one, and you acknowledge the view process to continue or stop that way. So you can build a classical function like folding, etc. on top of that. Like I already told, any database change are also indexed, so you can listen on any document change. Change are incrementals, meaning that if you have a new revision, you only get that new revision the next time you are creating the change. And you can filter the change by functions, but also by keys, like I will show. And you can also persist the filtered view change on the disk. One interesting part of that is, generally speaking, especially if you're coming from CouchDB, by default you are creating the change, and you get a sequence, last sequence, and when you want to go back on the change feeds, you are creating since that sequence that you store it somewhere. But if you lose the sequence for any reason, then you have to query back the change from 0 and pass the function again over that, which is very time-consuming and very CPU-consuming and memory-consuming. When you query just in index, it's quite faster. And you can also listen on change, subscribe to the view change. So you can subscribe, there is a typo here. You can subscribe to a part of the key, and when a key is updated in the view, then you get a change based on that. And you can also persist it. Everything of these features are very simple, and I want to keep them simple. If you want to build your own query engine like SQL or anything fancy you want to add, GraphQL, whatever, then you can do that using a view. But for me, the main interesting part is to provide a way to create that custom data platform you want, because this is what I want to do with the customer, and each customer has his own views on the way he wants to use the data. So the main point is to create a custom data platform mixing local and remote storage with different peer-to-peer strategies. And for that, you have the replication, which is simple. You start a replication tag saying the source and target. It doesn't have to be a local source. Everything can be remote, so you can query a remote source and put the data on a target. So it basically acts as a proxy or as a gateway between the replications. It works in a push or pull manner, so you can query you can replicate forms a node to another node, but replicate at the same time from that node to the source. In any case, so you can do both. So you have synchronization between nodes at the same time. The push-pull replication is using change feeds, obviously. So this is why you have the revision tree. It handles the conflicts when it's basically replicate all the conflicts and make sure to write them on the nodes you want to replicate the data. And you can push-pull the replication in any way. That's basically what you have already here on the master or on the P2 branch. And what's coming and what is already working for some customers is the replication topology feature, something that is working automatically and depend on the information you have on the network, on the view you have on the network, on the node that are discovered. Then you can start to build a replication topology strategy. And for that, you have two concepts inside Parallel, which are collaborators and remote nodes. Collaborators are mainly nodes that maintain collectively data sets. So if you want to make a hierarchical storage, meaning you have some very recent data on your node in memory, and you have that data persisted at the same time to a persistent node later, these are collaborators because when the nodes become full in memory, then it starts to evict the data from its nodes. And when you want to query the data, it will start to ask to that node, but that node will also ask to the collaborator, is there something more to give to the client? And the client doesn't have to know anything about that. You just query the main node. And remote nodes are basically the one like a remote worker that are working on their own sites, managing their own clusters and doing their own things part of the data. It uses TCP to extend the powerful TCP and Erlang distribution rebuilt over that using my telepo, which is not the same telepo as you. I don't know. I didn't know the name before it was told me by Tyson that one of you existed. But this is a full RPC things based on TCP with channel features and some other things like pluggable storage for TCP. So you can put SSL, but my point is to put in the noise protocol also on that to handle more distributed things. Or use anything like libp2p or what is provided by the gossip library. It discovers nodes by gossiping their presence and some tags between the nodes. You can build different topologies. So at the moment, there are two things tested. So the most tested right now is Partisan, which is a gossip library, but also a library that wants to replace the Erlang distribution. It's quite complicated to handle that because it's not really documented and very work in progress. But we managed to have something mostly working on that. The other one that I'm also trying to use is Erlang libp2p, which is kind of the same result than Partisan. I like some documentation for that. But we also have some part that is working on the nice thing with Erlang libp2p is that with Partisan, I have to build all these exchange between nodes. I have to build the address book, mostly, to maintain the list of the peers, etc., and stuff that are coming mostly for free with Erlang libp2p, at least how I expect to use that. And that replication topology, if this is not something fixed, you have dynamic rules that are created by a function that you upload in the system. That function is actually in Lua and not in Elixir because it has to be exposed to the clients. And you, for example, want to create some kind of topology based on the location in a data center. So in data center, you have mostly geo data center, which are two remote data centers at different places. You have your cluster in the data center that is a set of nodes, and you have the rack and the row on that rack. And then that creates an address. That rule will describe the replication path. So if, for example, you want two replications to in the same row, you set up the replication rules to set in the row with two replications. You want two replications in the rack, same cluster, etc. And then the replication will build a dependency tree based on the gossip information it got and start to replicate on the best path it wants to. So it will remove for you some network hops you don't really want during the replication. Like if you have a data center that is connected to another data center, it will try to take hot nodes that are more connection to between the data center rather than opening its own connection for that. So it will forward the message. And I'm mostly finished. What's next? So in Q1, so next month, I would say the week when I came back from skiing, that will be released, Barrel 1.0, finally. And in Q2, we'll have definitely finish to open source the replication platform and all the replication topology rules you will see. And that's all for me. You can contact me here on the website, and the website has the forum, etc. And any contribution are welcome from anyone. Thank you.